In this video, we are providing an introduction about Safer Drive AI solution, automated stress testing through AI agent. So the core of our system is the vision language model-based testing agent with access to multiple real-world data sources and multiple AI-driven and generative AI-driven solutions tools for it to better validate and evaluate autonomous vehicles. So the data sources will come from real-world map, the weather, the traffic environment, traffic patterns, driving trajectories, and different challenges and corner cases or crashes. And the vision language model-based testing agent will automatically fetch and inference all the information and propose different potentially unknown risks. And this will be provided through our open source submission core and API for integration with customer workflows. And also, we have the reinforcement learning driven naturalistic and adversarial driving environment to really mimic the real world traffic pattern while maintaining intelligently challenge the autonomous vehicle to improve the traffic efficiency and uncover the unknown unsafes. And also, we want to further translate what we understand into what autonomous vehicle understand. So we are providing the sensors dimension, including cameras and lidars, using generative AI. And finally, we are providing the performance evaluation. So this will be multiple rounds. We utilize what autonomous vehicles performance is to update our testing strategy. So we will support our long runs, hundreds of real-world like traffic agents, and the full city scale. We are essentially converting a lot of manual crafting, which can take engineer months work, into GPU hours to improve the testing coverage, lower the testing cost, and improve the testing efficiency, and find the unknown unsafe events before autonomous vehicle hits the road. So the first part is the designer agent. Essentially, we are designing the unknown unsafe events. So let's take Nixon and Green Road in Ann Arbor. This is a roundabout as an example. The designer agent will get information of the location and will automatically fetch through real-world related crash reports, news, and web information to propose different potential unknown unsafe events. So you can see they're providing us three candidates: the pedestrian fatality, the aggressive driving, and road closure. And also, we are using an example, which is a failed to yield collision at the roundabout, and the evidence is from the police report in 2020. So if you have interest, please click the link in this video and try it online to see if you can actually find unknown unsafe events around arbitrary location in the world. Still, the next step is to utilize the executor agent to translate the design into testing configuration. We're still taking this field utilization example, so the executor agent will fetch the information provided by the designer agent, which includes the map, the time, the traffic, and dynamic adversity. It will influence and make sure what is the detailed parameters. And also, it will get information about the description of the corner case or unknown unsafe events. And it will take information from the HD map source and the traffic API providers to construct the final testing configurations, including map, time, traffic, adversity types, and this will be provided through TeraSim open source core and will be integrated further into NAD, the naturalistic and adversarial driving environment. Through here, we have two different paths. The first one is the closed loop code simulation API. So this will automatically integrate into customer simulators to test their autonomous driving stacks within their existing workflows. And the second one is the generative AI-based sensor simulation so that we can provide the synthetic full stack corner case to validate both the perception system and the planning system and the control system all in one. So here's the example about the executor agent. It will automatically fetch the map. So you can see this is the map fetched, and the traffic behavior, traffic environment is also constructed with low traffic density. The next step is naturalistic and a zero driving environment. So after we generate the map, the traffic pattern, all the different configurations, we are utilizing naturalistic and a zero driving environment. So here, the two example is showing the red vehicle is the autonomous vehicle, and the background traffic participants is in blue. So the naturalistic driving environment, essentially, we are using imitation learning from large-scale driving dataset. This can also be fine-tuned utilizing customers' driving trajectory dataset, and we will measure the local traffic pattern as driving behavior or pedestrian behaviors is simply different across different states and different cities. And we support city-scale simulation purely running on GPU, a highly efficient framework, and it supports complex non-horizon and multi-agent interaction. So this is even better than human design as it can design multiple hundreds of agents for a long time horizon, which is not acceptable by just simply manual craft. And aside from naturalistic driving environment, we also provide the adversarial part. So this is supported by our patented simulation engine, which is published in Nature Cover in 2023 as the first reinforcement learning system for AV validation. So we are using reinforcement learning to automatically create different kinds of challenges, including static, dynamic, and behavior challenges. So in this example, we are showing the behavior challenges where the blue vehicle should yield to the red vehicle, but they actually fail to yield. But this is still based on our base of naturalistic driving environment while maintaining the realistic vehicle behaviors and supports 10,000 times faster than existing workflows. And aside from the behavior challenges we just showed, we can also do static, dynamic, and including behavior challenges. You can see construction zones on highway, unprotected left turn challenges, the mixed traffic flow with cyclists and vulnerable users, and even police cars, ambulance, and etc. And here we are showing an example still using the fail to yield collision example. So this is generated through what we said the TeraSim and the NAD. And the corner cases, you can see the two vehicles collided into each other because of the fail to yield collision. And we want to introduce the generative AI driven sensor simulation here. The right hand side is the street view image of this exact roundabout to give you a brief idea of what it looks like. And then we're generating the corner case here. So we are mimicking the traffic environment, translating the scenario we just generated in TeraSim into fully diffusion model based generative AI driven sensor simulation. So you can see this is exactly the same field to yield equation. And aside from just the front view cameras, we can also support flexible sensor configuration, including cameras and LiDARs. So you can see this is front view camera, still the field to yield equation at roundabout, and we can do this. We can do the surrounding cameras and all the traffic agents, the background, and the map is perfectly synchronized with each other. And all of this is purely simulated on a very highly efficient GPU framework. So here's the final idea of our testing framework. So we are using the roundabout as an example at the very beginning, but the final objective is that we can support the city scale safety testing for AV deployment. So here's an example about what our system can go through all the different locations in the Ann Arbor city. And here are some examples. So you can see there's a highway cutting collision within TeraSim, and we have the downtown police car TeraSim integrated with third-party simulator. And the right-hand side is the two examples of the corner case generated. One is located in the suburban area with a field to yield collision and roundabout. Another one is the pedestrian jaywalking utilizing our TeraSim world model.